For part C, it says that given that f of 2 equals 4, find the following values and determine the absolute max. So to find coordinates of f, we can use this generalization. We have some starting point f of a, and we're going to take the area under the derivative of f from that starting point a to some point x. X would be the endpoint of that interval. Okay, so if I want to find f of negative 2, I have to start at f of 2. That's my starting point. Okay, so f of 2 is my starting point. So to find this then, I'm going to start at f of 2, which the value is 4. And maybe I'll just do it in notation first. We have a starting point of f of 2, and then we're going to add the area under that derivative function from 2 to negative 2. Now notice that we're integrating right to left, so we have to be careful of that. And that's going to be under the f prime graph. Okay, and that's the graph that we're given here. So I'm going to just start filling this in. This is going to be equal to 4 plus, now the area from 2 to negative 2. From 2 to negative 2, that area, so I start here and I'm integrating backwards in this direction. When I'm integrating backwards, this area is positive. That area is positive here. And that area works out to be a 2 by 2 divided by 2, so area of 2 units. Now, it's important to note that we could calculate this area and this area as well to get all the way to negative 2. But since those areas are symmetrical, I'm just going to count that as 0. And the net area is going to be positive 2. So it's positive only because it's going right to left and it's below the x-axis. So that area then becomes plus 2. And the y-coordinate of f of negative 2 works out to be positive 6. So we're going to then compare these points and to figure out which of those points of interest are going to be our absolute max. So there's one candidate. So f of 0, we're going to go from, again, the starting point is going to be f of 2 is 4, plus the area from 2 to, let me just write this in, the area from 2 to 0. Again, notice that we are integrating right to left. In this case, that's going to be the same coordinate. So f prime of t dt, well, that's going to be exactly the same because from 0 to negative 2, it's a net displacement of 0. So I end up with 4 plus 2, and again, I end up with a y coordinate of 6. Okay, so there's 2 coordinates. F of 2 now is going to go from, we start at 2, well, we already been given that. Okay, so we know that that is equal to 4. F of 6, again, we're going to start at f of 2, and we're going to integrate or find the area from x is 2 to x is 6. Now, in this case, we're integrating from left to right, so area above is going to be positive, and area below is going to be negative. So when I look at the area from 2 to 6, I have this area in here. Okay, that area is positive 2. We have this little area in here. Okay, I'm going to work that out by calculating the area of the square. I'm just going to highlight the square for a second. The area of the square and taking away the area of that quarter circle. So that quarter circle is 2 squared pi divided by 4, which is pi. So 4 minus pi is going to represent that area, this little area in here. So that's 4 minus pi. So this works out to be from 2 to 6. So this is equal to 4 plus the area from 2 to 6 is going to be 2 plus 4 minus pi, which is 6 minus pi. So again, just there's my 2 and there's my 4 minus pi, that little area underneath that circle. So 6 minus pi. So that value then becomes 10 minus pi. Okay, so at this point, that is my highest point. I'm considering 6, 4, and now 10 minus pi. That is so far the highest point. And then if I'm going to consider f of 8, I have to add up the rest of that area. So this area in here is also 4 minus pi. So the net area from 2 to 8 is going to be 2 plus 4 plus 4, which is 10 minus 2 pi. So then working out that the y value at f of 8 is going to be the starting point 4 plus the displacement, which is going to be 10 minus 2 pi. And this represents the area from, and I'm just going to write it underneath, the area from 2 to 8 under the f prime graph. So that works out to be 14 minus 2 pi. So 14 minus 2 pi is going to be about a little bit more than 10 minus pi. So that becomes my absolute max.